those things, right? I think you must have doubt in the valency and the valence electron.
No,
Correct?
sir. Valency and valence electrons I've written. I wanted to know that in configuration, how will identify the N?
How will you write it about by what? By noble gas configuration.
Yes, sir.
Okay. So it is easy, no problem in that. Let's start with neon. So for helium, we don't have any noble gas that is nearest to helium, right? Before helium, we don't have any noble gas, so this will be 1s2. But if we talk about neon, what is the nearest noble gas after? Sorry, what is the nearest noble gas before neon? Tell me. What is the nearest noble gas before neon?
Helium.
Helium. So we'll start with helium. 2s2, 2p6, right?
Yes, sir. I got it.
Got it now? Similarly
Yes,
for
sir.
argon. Okay. Now, if you look at the valence electron, it is going to be 8 always for this. Okay. And the valency here will be 0. And that is why these are noble gases. That means they don't, generally speaking, they don't react. Okay. Generally speaking, they don't react. And that is why the name we have noble. Noble means they are not reacting with anything. Okay. Noble
Sir,
gases. Yes. What about others?
Electron can be 2 for helium.
Valence electron can be 2 for, yeah, correct. Valence electron can be 2 for helium. That is right. But generally it is going to be 8 only. And also since noble gas, they don't react, so we don't usually associate the word valence electron with the noble gases. Okay. But since we are writing with for the consistency, I've written valence electron will be 8 and the valence will be 0. But since they don't react, we don't associate this word valence, because valence is more related to how the reaction will happen with these particular molecules. And we will see how we are also going to write the molecular formula using the valence. Okay. What about Aisha and Aram? Did you write this for 15, 16, and 17, 18?
Yes.
Yes. Okay, fine. I think then we can move on to the next block, that is the D block. How are we writing these things, by the way? S block is in red, so the D block will also be in red. D block elements. Okay, so please write the element in which the element in which the last electron enters the d orbital of penultimate shell is called, rather we can write penultimate shell constitute the D block elements. Okay, so you must be wondering what is this penultimate? Penultimate means second last. So if you remember, if I start with let us say scandium Sc, this is 21, it will be argon 4s2 3d1. Now here if you see this, the last electron is entering in the third shell, right? Yes or no? It is entering in the d orbital of third shell, and third shell is the second last. Last shell is fourth shell, third shell is the second last, right? So the word, scientific word for that is penultimate. We don't write second last, it is not formal language. The formal language for this is penultimate shell. Okay. I hope you understand what are the D block elements.
Yes, sir.
Okay. Now write next point. The D block lies between. The D block lies between S and P block. S and P block elements. D block constitutes starts from group number 3 to 12. Okay, so for all of these electrons, for all of these elements, the general electronic configuration, it is always NS. NS can hold 0 to 2 electrons and N minus 1 D, and D will hold 1 to 10 electrons. Right, next. These are also called transition element. These are also called transition elements. Why? Because their property lie between S and P block elements. Okay, they are also known as transition element as their properties lies between S and P block elements. You will write next. The D block has 3 complete rows. It has 3 complete rows of 10 elements. And then there is one incomplete row. Okay, and then there is one incomplete row. We'll talk about what is that incomplete row after we have discussed with these 3 complete rows. Okay, the D block element has 3 complete rows of 10 elements and one incomplete row and one. So just write this much. इतना ही लिखिए आप लोग के लिए काफी. 3 complete rows of 10 elements. जब उस incomplete row के बारे में बात करें तब बात करें. Okay, so these 3 complete rows, these are known as first transition series, second transition series, and the third transition series. Okay, these rows are called first transition series, second transition series, and C1 is third transition series. Okay, so we'll talk one by one about the different transition series, the first, second, and the third transition series. Okay, so write the topic. Number A. Let me write all of them first of all. Okay. Look here. in the D block elements, what are the elements that you have to remember, that we have to remember? These elements are, it starts with first series, that is Sak, C, V, Kraman, Feko, Nikuzen. Sakti, Vikraman, Feko, Nikuzen. This is my first transition series. Sakti, Vikraman, Feko, Nikuzen. After that, below Sakti, Vikraman, below SC, we have, please write, second year Laenge AC. Okay, in second year, we will bring AC. Laenge means bring. Second year Laenge AC. Laenge means bring. We will bring AC in the second year. Then we have TI. So for TI, after that, below what you're going to write, T zara half. We should not eat much. We should not drink much tea. T zara half. Okay, so for the third, you have to remember all of them. इसके नीचे का आपको एक्रोनिम के बाद का आपको याद करने की जरूरत है. Okay, so you just need to remember these three, one, first, second, and third, that are more important. T zara half. And then for vanadium, you will write वो नवाब था. वो नवाब था. For this, we have chromoton. Chromaton or chromoton. And this, regarding manganese, there is a very important lesson that is also a life lesson. There are some things that you should not tell everyone. There are some things that should be, you should tell yourself that man tak re. Man tak re. Should not tell everything to everyone. And this is, you can remember this as ferrous, F-E-R-U-O-S, ferrous. Then those who want to go abroad, they can remember this one very easily. Kaun rahega Ireland. And I think you will relate to the nickel group very much. Nahi pada pata. Nickel PDPT. And for the copper series, it will remind you of your friends. Your friends who are always there when there is a fight. They tell you, kyun aage aau? Why should we come forward for you? Kyun aage aau? Okay, so we start with second year Laenge AC, T zara half, wo nawab tha, chromaton, man tak re, ferrous, kaun rahega Ireland, nahi pada pata, kyun aage aau? And then you will remember this one for the sake of chemistry, ZnCdHg. There is nothing here. You have to remember for this for the sake of chemistry, ZnCdHg. We have got the mnemonic for all of the other elements, but for the last one, we have not got. You have to learn this just for the sake of learning it. Okay. So please, I will give you some time. So this is my third. This is the third period. This is the fourth, fifth, sorry, group, sixth, seventh group, eighth, ninth, 10th, 11th, and 12th. Okay. And then from 13, so from 13 to 18, we have the P block elements. So please write this down. And then I will give you 2 minutes. Please say it on your own. Second year Laenge AC, T zara half, wo nawab tha, chromaton, man tak re, ferrous, kaun rahega Ireland, nahi pad pata, kyun aage aau, and ZnCdHg. Please try to say this a few times so that you will remember it. Now I think you can say that you remember, once you are done with this, you remember most of the periodic table, starting from the first group, second group, then 13, 14, 15, 16, 17, and 18. And then we have also done for the first transition series. You will start it like this, like Sakti, Vikraman, Feko, Nikuzen. You write the series. And then the SC will remind you of second year Laenge AC. TI will remind you of T zara half. V will remind you of wo nawab tha, chromaton, man tak re, ferrous, kaun rahega Ireland, nahi pad pata, kyun aage aau, ZnCdHg. ZnCdHg. Are you guys repeating this? Yes or no? Please tell me. Aisha? Aisha, can you read the fifth one? Tell me. Fifth group. How will you remember the fifth group, Aisha?
O Nawabta.
Very good. Iram, the ninth group. Iram, ninth group.
Con Reza Island.
Very good. Devangi, the seventh group. Tell me. Seventh. How will you remember the seventh group?
Mantakre.
Bantakre. Very good. Okay. And Fatima, you want to try?
No, sir.
No, you don't want to try. You can try the last one, I think. 12th. Tell me. How will you remember the 12th one? ZNCDHG. But what about the third one? Tell me. Fatima, you can try the third one.
No.
No. See, most of the words you know these words, right? Second, you know this word second, right?
Yeah.
Second year, La AC, you can say that in the second year, you have to do so much of struggle that you don't want AC in the second year, right? Second year, La AC. That means no AC. I hope that makes sense. Yes, Fatima?
Yeah, sir.
Yeah. So how will you remember the third group? Tell me, Aisha. Sorry, not Aisha. Fatima. Not Aisha. Fatima. Third group. Can you say it once at least? Second year La AC.
Second year life.
Second year La AC. Okay, fine. We'll think something about the fourth group also. So fourth is I mean, there are two words that you remember that you must know: T and half, right? Yes or no?
Yeah.
Yeah, T and half. And Zara means little. Okay. I don't know. Zara. I don't think it is. You know what is the meaning of Zarra? Like the sand and all? Fatima?
No.
No. Okay. My bad. Sorry. Okay, fine. Fahad, tell me about the 10th one. 10th group. Nahi pad pata. Okay. Muhammad Abdullah, can you tell me what is for the sixth group? Chromoton. Chromoton. Why it is ton? Because it is okay. It is tungsten actually. Okay. This W is what? It is tungsten. I learned about this tungsten in a very funny way actually when I was not in even 11th standard. So tungsten is used for what? Tell me, guys. Tungsten is used for what? What's
Filament
tungsten
of
used?
bulbs.
Yeah, very good. Filament of bulb. So the bulb filament, it looks something like this. Can I say that? Right? Yes or no? Correct. This is the filament. And you just reverse it, you will get the atomic symbol for tungsten. Okay, so tungsten is W. Fine. Now we'll look at some special things about the first transition series, second transition series, and also the third transition series. Okay, so please write. First transition series. Now in first transition series, we start with scandium, Sc21, to zinc. Its atomic number is 30. Okay, and this is in the fourth period. And which is the d orbital that is getting filled here? 3d orbitals. Are gradually filled. Okay, 3d orbitals are gradually filled. In this, you will remember the electronic configuration of chromium. So chromium is argon 4s1 and 3d5 rather than 4s2 and 3d4. And for copper, it is argon 4s1 3d10. These are the anomalies in electronic configuration due to the stabilities of symmetrical electronic configuration of 3d5 and also due to the exchange energy. Then write the B second transition series. It starts with yttrium. Its atomic number is 39. To cadmium, whose atomic number is 48. And it is in the fifth period. And in the fifth period, the 4 d orbitals are filled. Then write the C part, third transition series. Now in the third transition series, we start with lanthanum, which is 57, to hafnium, hafnium is 72. Okay, and between 57 and 72, the 4 f orbitals are filled. Okay, and after hafnium, because in between lanthanum and hafnium, we have the f block element. Okay, so from hafnium to mercury, we have the rest of the d orbital, which is 80. You can also write for the fourth transition series. Okay, in this, what is going to be filled? This is the sixth period. Five d orbitals are filled. Fourth transition series. It starts with actinium to Rutherfordium and then to Copernicum. Start with actinium, whose atomic number is 89, to the next element, that is Rutherfordium. In between, we have the F block elements, and for Rutherfordium, the atomic number becomes 104, to Copernicum. And for Copernicum, the Z is equal to 112. This is the seventh period. 6d orbitals are gradually filled. Then you will write some remarks about the d block elements. So most of these metals, most of the d block elements, these are metals. They are metal. Having high boiling point and melting point, except mercury, which is liquid at room temperature. Okay. So all of these are metal except mercury. Similarly, if you see at room temperature in the p block elements, bromine is the one which is liquid. Everything else, it is either gas or it is solid. Okay. So we have bromine and mercury, which is liquid at room temperature. Otherwise, everything is either solid or it is a gas. Right, next. Most of them form colored compound. Right, next. They show variable. You can write variable valency or oxidation state, variable oxidation state. Okay. You write last point. Many of the elements, many of D block elements are used as catalyst. Then we'll write a small thing about the F block element, and then we will go towards the main part of this chapter, that is the periodicity. In properties, we will look at several properties. That is the main part of this whole chapter. By the way, Fahad,
Yes.
do you have any other doubts?
No.
No? Okay, fine. Fatima, how is your preparation for the exam? When is your exam, by the way? 7th, or what did you say, 9th?
Starts on Wednesday.
It's like tomorrow.
Next Wednesday. The next week.
Next Wednesday.
Yes.
Okay, fine. So I actually did one small session with Fahad. Can you remind me, Fatima, tomorrow? Okay.
Yes.
I will send you the recording. Actually, I was finding the recording of the previous year, but I could not find anything. I mean, we have so many videos uploaded that even the search is not giving me any good result. Okay. So I could not get those videos, but I think I should get the video that we have done with Fahad. Okay. Many of the D block elements are used as catalyst. Okay, right, next. F block elements. Fourth part. F block elements. Right here. The elements in which last electron. The elements in which last electron enters the F orbital are called F block elements. All right, next point. In these elements, the last electron is added. The last electron is added to the third outermost energy level or shell. Noma. third outermost shell. This third outermost shell, it has another name. It is known as anti-penultimate. Anti-penultimate. Pen. Okay, anti-penultimate shell. That is n-2f. That is n-2f. Okay, so it consists of two series. So we have lanthanum, and after lanthanum we have lanthanoids, and then we have actinium, and after actinium we have actinoids. Okay, so please write. It has two series. Number A. Right here. The first series is known as lanthanoids. You can also call this as lanthanides. Lanthanoids or lanthanides. Now, this series follows what? It follows lanthanum, which is Z is equal to 57. Atomic number is equal to 57, and the element present between cerium, and at the end of this series we have lutetium. Cerium, which has the atomic number of 58, to Lu, lutetium, which is 71. These are also called rare earth elements. Right, for the second one, these are known as actinoids or actinides. Actinoids or actinides. This series follows actinium. Actinium has the atomic number of 89, and the elements present between, thorium, which is 90, to lawrencium, which is 103. We'll write next. These are radioactive elements. Then you will write some remarks. In remarks, you will first write the general electronic configuration of F block. Okay, so you don't have to remember this actually, but it is easy to remember, so you don't have to worry. We have NS2. Okay, there will be NS2, then N-2 F. It will be from 1 to 14. It will be gradually filled from 1 to 14. Now n minus 1 d will also be there sometimes. And in D, you will fill either 0 or 2 electrons. Okay, 1 or 2 electrons. 0, 1 or 2 electrons can be there for the D. ns2, n minus 2 f, and np is not there. We have to. Sometimes the d orbital is also filled. It is because of relativistic effect. You don't have to worry about it. You just write this general electronic configuration. Most of the time, it is never asked. Now, about the characteristics, these are known as heavy metals. They are heavy metals, please write. They are heavy metals. Generally have high melting point and boiling points. They exhibit variable oxidation state. Last point is important. Sometimes they ask you for 1 marks. Please write this. The elements after uranium. Are called trans-uranium elements. Okay, it is an easy question. People generally miss it. That is why we don't. Done, everyone? Yes or no? Please tell me.
Yes, sir.
Okay. Now, see, when we have the periodic table, so you will generalize the periodic table into 4 different categories. In chemistry, we generalize the periodic table into 4 different categories. The first category we say is the noble gases. Why? Because noble gases, they have a similar property that they don't react very much, right? These are noble gases. Noble gas, right? This is group 18 only. This is group 18. What is important about them? They don't react easily, right? They are, we can say, chemically inert at ordinary conditions. We can say at room temperature, chemically inert at normal conditions, right? Then we have the next, which is known as the representative elements. These are S and P block elements. Okay, all of the S and P block elements, they come under this category of representative elements. Okay, so because these are the elements which are mostly found in the earth, right? And these are the elements which do the majority of the chemistry. That's why these are known as representative elements. Then we have one more, which is known as transition elements. I hope you know this one. We have just learned it. Transition elements. Transition elements are the D block. And then we have the inner transition elements. These are the F block elements. Okay, so most of the chemistry is done here within the representative elements. Okay, Most of the chemistry happens here only. Done everyone? Yes or no? Please tell me.
No.
No. Write it down then. Done everyone? Yes or no? Please tell me. Still writing? Okay, since you are writing, you will write one more thing. Please write this with me. Limitation of modern periodic table. So there are basically two limitations. The first limitation is the position of hydrogen. Position of hydrogen is not fixed. It represents both the alkali metals and halogens. So the hydrogen, it can be placed in either the first group or it can also be placed in the 17th group. Second is the lanthanides and the actinides, the F block, they have not been accommodated in the main body of the periodic table. They have been kept separated, right? So we will write the F block elements. Are still not accommodated. In the main body of periodic table. Done everyone? Yes or no? Please tell me. Done everyone? Yes or no? Please tell
Yes,
me.
sir.
Okay, fine. Now we will write the properties. Okay. Periodicity in properties. Okay. So first of all, why this periodicity is seen? Why there are periodic properties? So we'll write They can ask you a simple question. What is the cause of periodicity in the periodic? What is the cause of periodicity in the properties of elements in the modern periodic table? So we'll write a repetition of similar electronic configuration of atoms in the outermost energy shell. Devangi, did you get time to watch the lecture of quantum numbers? Repetition of similar electronic
Yes,
configuration of
yes.
atoms in the most defined. So you now understand what is energy shell, energy levels, right? Yes or no?
Yes, sir.
Okay. After certain regular intervals. Okay. Now there are few properties that we are going to look. So properties that we are going to study. And all of these properties are very important. Okay. So this is going to be helpful in your 12th standard also. So please learn all of these properties. These are very logical properties. And slowly, we'll learn all of these. First one is, please write the Z effective or the effective nuclear charge. Effective nuclear charge. In NCERT, this effective nuclear charge has been mentioned in the chapter 2 itself. But since it is more appropriate to write here, we are going to learn about this property in this chapter. Okay, and also it just mentioned the effective nuclear charge. It does not tell you about the different periodic, like how it is getting increasing or decreasing, what is the trend here. Then the next property is atomic size. Now in atomic size, we will talk about a few things, like how is the atomic size or the atomic radius measured also. That is also something we will be learning, and about different elements. The next one is ionization enthalpy. Enthalpy is nothing, it is just energy, but energy which is measured in constant pressure. When we talk about energy, when physicists they talk about energy, that energy is in constant volume. Okay, but when we chemists talk about energy, this energy is in constant pressure, and that is why we use a different term, that is enthalpy. Then we have electron gain enthalpy. And at last, we will learn about electronegativity. So see, this effective nuclear charge, it is going to judge all of the other properties. So mainly we are going to learn these four, but the effective nuclear charge is the one which will be governing all of these things. Okay, so the trend, it will be governed by the effective nuclear charge. Write the first one, effective nuclear charge. All of you wrote this now?
Yes.
Let us understand first of all what is effective nuclear charge, which is written as Z effective. Okay, now if I look at protons, let us talk about the sodium atom here. Okay, let us talk about the sodium atom here. So sodium will have 11 protons, right? And then there will be some shell. Let us suppose that this is the first shell. The first shell, it will have 2 electrons. Right? I'm showing the 2 electrons here only, very nearby, but it will not be this nearby. Then we will have the second shell. The second shell will have 8 electrons. 1, 2, 3, 4, 5, 6, 7, and 8. Again, I've shown all of the 8 electrons in a very nearby region. They will not be this nearby. And then we'll have at last the third shell. And this third shell will be a bit larger. The third shell will be occupying only 1 electron. There will be fourth shell also there, but this fourth shell will not be available. It will be vacant. That is why we don't draw the fourth shell. Each and every atom, it has infinite number of shells, but we only talk about those shells which are occupied. And these shells, these are not in terms of physical spaces. These are in terms of energy levels. Okay, so the electron, if it is having the energy which is equal to first shell, then we say that it is first shell. It is not, I mean, it is not as circular as you can imagine. Okay, an atom is so small that the things that happen here, that things that happen actually inside the atom, they are not very much comprehensible, and they don't have any example that we can set in the general world that we see, the macroscopic world that we see. The electronic world is completely different. So this is just a model. Okay, for example, if I say a car, so there is a car that is something, right? Then we have a model which is, say, let us say that it is made up of Lego, right? And there is some model which is made up of thermocol. There is some model which is made up of steel. So all of these models are models of the car. They are not car exactly. So what I am drawing here one is it is a model of an atom. It is not the actual atom. It is not telling you everything about the atom. See here, I have not drawn the different S subshell, P subshell, and so on, right? Here I've just drawn the shell. So this is one model by which we are going to understand all of these different properties. Okay, and we complicate the model as per our need. If much complications is not required, we don't complicate the model. Okay, so the model that we are using right now, it is the shell model, that we have the first shell, second shell, and the third shell. Please keep these things in your mind so that you will be not having much confusion. You'll say, sir, SPDF padha to SPDF padhaiye hame. No, all of these properties, they can be explained by shell. That is why we are not dealing with the SPDF shells, subshells right now. Okay, but slowly we will include those complications and those complexities also. Right now, we will be looking at this electron that is the outermost shell. This is my electron of choice. This is my electron of choice, right? Now, this electron here, it will be facing some charge. This proton here, it will be attracting this electron. But tell me, if I have an electron like this and I have a different situation, let me tell you like this. And I will be doing this type of comparison many a times. Okay, I will be doing this comparison many a times. Now, we have two different situations here, A and B. And the difference in these two situations is that, oops, sorry. We don't have the electrons in the B case. Okay, so here we have A case, and here we have the B case. Now tell me, in which of the cases this outermost electron, this green electron here, it will be facing the most attractive force? In the A case or the B case? Please write your answer in the chat here itself. I want to see how you people are thinking here. The electron here, it will be facing attractive forces in A more or the B more? Kahan pe zyada face karega? Okay, Fatima, where will it face more attraction? Okay, Aisha, very good. I think, okay, fine. Where will it face more attraction? I'm just waiting for Muhammad, Abdullah, and Iram. Iram, you have not answered. Yes. What about Abdullah? What do you think? Abdullah has not answered. No, Abdullah has not answered. Muhammad, Abdullah, what do you think? You're not answered anything till now. Oh my God, is he there in the class? Fair. Now, all of you agree that the B will be facing more attraction. That means, can I say, these inner electrons, these are protecting the outermost electron. They are not letting the positive charge to get towards this particular electron, and they are shielding or screening the charge. Okay, it is screening the nuclear charge. So we say that these electrons are shielding, or they are screening the Z. What is Z? Z is the nuclear charge, the number of protons that we have. All of you understood this point? Yes or no? Please tell me. Aisha, Devangi, Iram, Fahad, Fatima, and Abdullah. Yes or no? Please tell me that these electrons, they will be limiting the effect of the nucleus here. They will be limiting the effect of protons' attractive forces. Yes or no? Please tell me, guys. These are shielding or screening the Z,
Yes, sir.
right? So what about others? Huh? Aisha, Iram, Fahad.
Yes, sir.
Okay. Now that means the effective nuclear charge that this green electron is getting. Effective means net electronic charge. The net charge that it is, the net nuclear charge that it is getting, Z effective, is equal to the nuclear charge minus the effect of this shielding here, minus the screening effect that is shown by sigma. Okay, so sigma is what? Sigma is nothing, it is shielding. Okay, so we are not going to calculate the Z effective, but we will have an idea what is the Z effective here. Okay, so please write first of all what is shielding. Right here, shielding or screening. Right, the reduction in nuclear charge on the electron due to the difference in attractive forces, due to the difference in attractive forces on the electrons of atom. Okay, so that is the reduction. So now we will not talk about always the nuclear charge. That means how many protons do we have? We also have to look at the shielding effect. So we will be talking about the Z effective. Please write the first point regarding the Z effective here. Z effective depends on the first criteria is size of atom. Size of atom. So if the size of atom will increase, the effective nuclear charge will decrease. Z effective is inversely proportional to size of atom. You can also write the same thing as size of atom increases, size of atom increases, Z effective decreases, because you can say that if you have a proton here and the electron is moving here, and then we have another case, the electron is moving here. So obviously all of you will say that A will face more effective nuclear charge. A will face the attraction more dominantly than the B case, and B will face less because the size of atom has increased. The electron and the proton are far away, so they will be attracting themselves in a much lesser sense, in a much lesser magnitude. Next, it depends also on the shielding of different orbitals or subshells. Second point. Shielding of different orbitals. Okay, different orbitals. Okay, I will talk about something. Just don't write this after shielding of different orbitals. Tell me. I'm drawing two things here. A and this is B. Which is more diffused? I just want to know whether you know the idea of this word diffused. Which is more diffused, A or B? Which is more diffused, A or B? Correct, Fahad. Which is more diffused? I just want to see an idea, like whether you can recognize or not. Which is more diffused? And diffuse, opposite of diffuse will be concentrated. Which is concentrated and which is diffused. These are two different things, okay? Diagonally opposite. What do you think? Which part is more concentrated and which part is more diffused? Okay, Devangi. Okay, Fatima, Fahad, Iram. Okay, so what is that? Diffused, Iram?
Yes.
And B is more concentrated? Iram, tell me.
Yeah.
Yeah? Okay, then you have to change your thing. Okay, so B is more diffused, A is more concentrated. Because see, diffuse का मतलब क्या है? Diffuse means it is spread over a large area, right? Diffuse means what? It is spread over a large area. See, you have perfumes, right? You have perfume. Like when the perfume is in its own bottle, it's what? It's not diffused right now. But as soon as you spray it, it diffuses and it goes all over towards the room and everyone can smell it, right? So that is diffuse, right? So that is diffusing. Okay, so B is more diffused. Got it, all of you? Yes or no? Please tell me.
Yes, sir.
Iram, what about you?
Yes.
Yes, no problem, na? Okay, now we have different orbitals S, P, D, and F. Now we know that S has this shape spherical. P is what it is? Dumbbell. D is double dumbbell. And F is very much complicated, right? It is complex. But we know that it is going to have 8 lobes. It is going to have 8 lobes. Can I say that if I go from S, P, D, and F, in this way, what is happening? The diffusion is increasing. F is more diffused. There's an increase in the diffused orbitals, right? F is more diffused than D, then P, then S. Yes or no? All of you got this? Any problem till here? Any
sir.
problem till here? What about others? Aisha, Iram, Fahad, Fatima, please tell me.
Sir,
Can I
explain
say,
it again?
I'm saying that S is less diffused, then P is more diffused, D is more diffused, and F is most diffused all of these out of these orbitals. Right? Because as you can see, it is concentrated, and as you go towards P, D, and F, they are increasing, their area is also increasing, right? Fatima, yes or no, tell me.
Yes.
I hope you can see that S has more similarity towards the A, and the D and the F, they will have more similarity towards the B. They are more diffused. They are, अब फैला हुआ को क्या बोलते हैं इंग्लिश में? Iram, what will be the word for फैला हुआ? Spreaded. So we can say diffuse. Another word for diffuse will be which is more spread, right? So F will be more spread rather than S, P, and D. Okay. Now, what do you think? If S is more concentrated and F is more spread over, which is going to shield effectively? Which will have the more shielding power? Which can surround the nucleus more effectively, and it can take all the attractive forces and it will not let the attractive forces go away from it? S or F? Which is going to shield effectively? Which is going to shield effectively? Devangi, can you tell me your logic? Yes, Devangi?
Sir, because F is more diffuse, like it
It's
covers
more.
more surface area of.
So if it is more diffuse, then it will be also further away, right, from the nucleus. Yes or no?
Yes, sir.
Right. So if you want to, like, also one more thing, if you want to shield you, if you want to protect someone, then you, like, if you are many people, then you cannot spread here and there. You have to be concentrated and you have to protect that one person. Right here, what we are talking about here, we are talking about the protection of that nuclear charge. Now, if you want to protect the nuclear charge, then it should be concentrated and you should be protecting it from very near. Okay, and that is why if I talk about the shielding power, since S is more concentrated, S will be nearer to the nucleus and S will shield the most. The sigma of S, that means shielding power of S, is the greatest, followed by sigma of P. And the D and F, these are very much diffuse. That is why they don't have much shielding power. Okay, they are very far further away and they don't have much shielding power. S, and then we have D, and then we have F. So this is the shielding power of the different subshells. Okay. All of you got this? Yes or no? Please tell me. Okay, Fatima, any doubt? You're convinced by this or no?
Yes.
Yeah. Okay, fine. Okay, so till now we will learn about, we will just remember these things, that Z effective is what? It is increasing if it is decreasing if I increase the size of atom, and we will say that the shielding power of different orbitals, S is more than P, then D, then F. And we'll be using both of these things eventually in the different properties. So we have done the first properties, we will write the second property, that is atomic radius. Okay, by the way, wait a second. Also one more thing is से पहले what is the trend of this graph? This graph is going which direction? Upward? Yeah, no. Is it going upward? Can we say the trend is upward? Let us suppose that this is the graph of your stock market, or this is the graph of your run rate after different overs, if you watch cricket. Okay, so can we say that the run rate is increasing, it is going upward, or what would we say? We're going this direction. Tell me, guys. Devangi, Iram, Fahad, Fatima, Aisha, Muhammad Abdullah. Can we say the trend is upward? No.
Yes.
Yes, no. All of you agree with this? Okay, so we will be looking at trends only. Okay, that is why I wanted to show this graph, because see, we have ups and down, but eventually we are going upward, right? So that is why the trend is upward. So when we'll be talking about two things. We will be talking about the trend eventually, and we will also be looking at these why it is going up then down then up then down. So we'll be talking about those things also. But the trend is going to be one thing only. Okay, so right for Z effective, if I talk about the Z effective, the trends. Wait a second. Trend for Z effective. If I look at Z effective, then I can say that down the group, as we are increasing different shell, because as in down the group, what is happening? Different period, and period represent the shell. The size is increasing, and that is why the Z effective will decrease down the group. We can say that the Z effective decreases okay. And along the period, we are adding more number of protons in the same shell, right? If I talk about the second shell, then we are adding protons, but the size is not increasing. So we have more and more protons and more electrons. So all of these protons will be attracting these electrons. So we can say that in general, what will happen to the Z effective along the period? The Z effective increases. Okay. Right, next, atomic radius. Will be the least for noble gases. No. And generally, when we talk about the properties, na, we generally don't talk about the noble gases. Aisa nahi hai. Like when you are saying along the period, the Z effective will increase, na. So for noble gases, it will not be the least. Okay, it will not be the least for noble gases. Rather, it will be the most for noble gases, because along the period, Z effective is increasing, na. Got it, Devangi?
But sir, I think noble gases have the largest atomic size.
We will see why do they have largest atomic size. Okay, that is due to the measurement. Okay, that is not actual. That is due to the measurement. We have different ways for measuring the atomic radius or atomic size. So right next, atomic radius. You will see why the noble gas they have the in one period now they have the largest size, right? So why is that? You will write next after atomic radius, distance from the center of nucleus to the outermost shell of electron. Okay. Now next one. See, we can't measure the radius of one atom. Okay, so please write measurement of radius of one atom is nearly impossible. Hence, we use some approximate methods. And these methods, they don't tell me the exact atomic radius, but they can infer us regarding the atomic radius. Okay, so we can talk relatively. ये इससे छोटा, ये इससे बड़ा, इस तरह की बातें हम कर सकते हैं. We can also give the numbers relative to this and that, but these are not exact things. Okay, because we are using what? We are using some approximate methods. We use some approximate method to infer the atomic radius. Okay, right, next. Usually, one of the following methods are used. One of the following methods is used. Right, number one, covalent radius. Obviously, covalent radius will be used for covalent molecules, that means non-metals. For covalent molecules, which are generally, I'm writing NM, NM is non-metal, okay? NM is non-metal. Then we use metallic radius for metals. metallic radius. These are used for metals. Then the third one is van der Waal radius. We use this for measurement of noble gases, the radius of noble gas. Van der Waal, okay. Right, number one, covalent radius. What is covalent radius? So for example, we have two molecules. Sorry, we have one molecule which is made up of two atoms like this. Let's make this green. Okay, and this is homoatomic. That means both of these atoms are same. Okay, and if those atoms they make any covalent molecule, for example, we have hydrogen, we have chlorine, we have bromine, all of these atoms they make homodiatomic molecules. Their nuclei will be here and here, just approximating the middle path. And this distance here, it is known as d. Okay, this distance is what? It is d. Okay, covalent radiuses. It is equal to d by 2. Okay, so can you see that we are approximating because there is some overlap between the molecules and the electrons of the molecules, right? So what is covalent radius? It is the half of distance between two covalently bonded atoms of same element. Okay, write a small question that will help you understanding this concept of covalent radius, right? Calculate the covalent radii of following. I'm writing the molecule and then I'm writing the bond length. This is the bond length, okay? And then we'll write the atomic radii. So let us say we have hydrogen, chlorine, and bromine. So the bond length it is measured as 74 picometer. Here it is 198 picometer, and here it is 228 picometer. ऐसे सवाल आएंगे नहीं आपको, बस आप एक बार यहाँ पे लिख दीजिए atomic radius क्या क्या होगा. It will be the half of the bond length, right? The distance between the two covalently bonded atoms, that is the bond length. Bond length का आधा atomic radii. Half of bond length will be atomic radii. Yes, Devangi. Okay, correct. Yes, Fatima, correct. Okay. Okay, I'm encouraging others also, so please write the answers in the chat also once you are done. Yes, Aisha, correct. Okay, so I hope you are getting a gist of it. So this is going to be 37 picometer. This is going to be 99 picometer. This is going to be 114 picometers. Yes, correct. Yes, sir, right. Okay, so this is how we measure. And see, look at the covalent radius, and then we are going to write about the metallic radius. Look at that. And tell me, what do you think, which is going to be larger, metallic or the covalent one? Just in terms of measuring things. Okay, so we have written covalent how? We have written covalent as 1, right? Second one, that is metallic. Now, metals, these are not present as homodiatoms. They will be present as lattices, right? You will have a block of metal like this, and this particular block, it will have some atoms in it, right? It will have some atoms in it. So I'm just trying this out. Okay. So at least I should have, let me see. Can I have 3? Yeah, I think I can have 3. It makes sense. Okay, fine. It's quite good. So the atoms of metal will be something like this. Okay, I think I have to increase the size. Yeah, fine. So this is a block of metal. We call it metal lattice. And if I talk about 2 different adjacent atoms here, these are the centers, and this is the distance between them. And the half of this distance will be the metallic radius, and this will be measured. And this same radius here, it will be called as the atomic radius of this particular metal. Okay, because what we are doing, we are approximating the atomic radius. So please write 1/2 of, this is 1/2 of 1/2 of internuclear distance between the 2 neighboring atoms of a metal in a metallic lattice. Okay, in a metallic lattice. Now, if you look at this, what do you think, which will be larger? Don't look at the size of this D, okay? Just see how we are measuring this, how the covalent atoms, how covalently bonded atoms are, and how the metal atoms are. Tell me, what do you think, which will be larger? The covalent or the metallic? What is the difference between the covalent and the metallic in the way of measurement and how the atoms are there? Can you tell me, Divang? Okay, someone has told me. Okay, fine. So all of you can see, right? The metallic radius is larger, but it is not because it is larger. It is larger because how we are measuring it. All of you got this? Yes or no? Please tell me. Aisha, Devangi, Iram, Fahad, and Fatima. Also, Muhammad Abdullah. I hope all of you can see that metallic is larger. Yes, Fatima, tell me. Yes, Fatima, you were trying to say something. Okay, I could not get actually. Okay, at last we are going to do van der Waals radius, that is measured for, that is used for the measurement of atomic radius for noble gases. Third one. van der Waals radius. Now, we know that the noble gases, they don't form any atom. So noble gases, when they will be present, so we have one helium atom here, right? And the nearest helium atom, it will neither be touching it nor it will be overlapping this helium atom, right? It will be somewhere far away from it. Right? Suppose we have another helium atom here, right? The nearest helium atom is this atom here. Both of these are neighbors. Okay. Now we measure the distance between these two. Suppose that we are going from here, which is the middle of helium atom, and somewhere here, let us say this is the middle of the helium atom. Okay. Let us just suppose we are just approximating things here. Nothing to be taken seriously. So now this is the distance. And this is the smallest distance between the two noble gases, right? And van der Waals radius is what? It is the 1/2 of intermolecular, or rather internuclear distance between nuclei of two adjacent atom of, wait a second, let me write it, please write it with me. 1/2 of internuclear difference between nuclei of two adjacent atoms. Adjacent does not mean they should be touching. Adjacent atoms of a substance belonging to two neighboring atoms, two neighboring right molecules in solid state. Okay, so we bring them closer as much as possible, because we have done it, we have it in solid state. We bring them as much as possible, as much near as possible. Okay, but still you can see that the van der Waals radius, just by the virtue of its method of measurement, it is going to be the largest. It is going to be the largest. Okay.
So noble gases are measured in van der Waals radius.
Yeah, noble gases are measured in van der Waals radiuses.
But
And that
they
is sorry.
They are gases, right? They are written in solid state.
हाँ, so we measure them. Atom क्या होगा बताइए आप? Atom gas होगा, solid होगा, liquid होगा?
Atom तो atom है.
Atom तो atom है.
Solid होगा सर.
Atom क्या होगा बताइए? Solid होगा, liquid होगा, gas होगा? एक atom.
Solid.
एक atom solid होगा. What others think? Tell me. Aisha, Devangi, Fatima. Atom will be solid, liquid, or gas? One atom.
Yes.
Gas. Okay. What about others? Iram, Aisha, Devangi, Muhammad Abdullah.
Gas.
What do you guys? Gas.
Solid.
Solid. Okay. So see, these terms, solid, liquid, and gas, these are explained by the neighbors, right? If an atom has neighbors, that means it is solid. If an atom has a neighbor a bit far away, it is liquid. If an atom has a neighbor very far away, it is gas. So all of these things are bulk properties. What we say, these are bulk properties. That means, like, for one entity, you can't say whether it is solid, liquid, or gas, right? If you have thousands or millions and millions of atoms, then you can say whether it is solid, liquid, or gas. Okay, so these are bulk properties. These are not atomic properties. Fine. So we don't define that. Now what we are measuring, tell me. Fahad, we are measuring the atomic radius, yes or no? Right?
Yes.
Now this atomic radius, it is not going to depend on the bulk property, right? Whether something is solid, liquid, or gas, the atom will be atom, right? Those individual atoms, they will not change their state, right? Those atoms are as it is, but it is just that the atoms get nearby, then it becomes solid. If it is a bit far away, then it becomes liquid. If it is more far away, then it becomes gas. Now, what we have done for noble gases, we have got the most, like to get the most accurate measurements, we have got them into the solid state, right? But still, this noble gases, they will be repelling each other in solids. They will be very unstable in the solid state because all of them are, by inherently, they are gases, and that is why what happens, even when we get them into solid state, they vibrate a lot, and there is some distance. Always they are bit far away. They are always not overlapping like metals, neither are like covalent molecules. Okay, so they have their atoms are a bit far apart, and then we measure it. So we have what we are done, and let's suppose that we have the gases. Okay, in gases, one of the helium atom will be very far away from the helium atom, and after that, when we are measuring the distance between those two, that distance will be huge, right? That distance will be very huge, and that will not approximate towards the atomic radius. So what we are doing, we are approximating, and we are developing some scenarios in which we can get towards the nearest or the closest right answer towards the atomic radius. You got it, Fahad? Yes or no? Why we are taking the solid state?
Oh, yes.
Okay. Fine. Right, next, usually, like generally speaking, if we take something which has covalent molecule, also it has metallic property, also it has we can also measure it van der Waals radius. Then in that case, usually we see that covalent radius is smallest, followed by metallic, followed by van der Waals. Okay, now you will write periodic trend in atomic radius. Periodic trend in atomic radius. Now we will relate the atomic radius to Z effective. So we can say that if the Z effective is lower, the atomic radius will be higher, right? Atomic radius, it is inversely proportional to Z effective. Right, because if the Z effective is higher, that means nucleus is attracting the electron. If the nucleus is attracting the electron, the atom will be shrinking, electron will be nearer, right? The electron will be nearer, that means the size will be decreasing. So if the Z effective is high, atomic radius is low. If the Z effective is low, atomic radius will be high. Okay, so you can talk about this in terms of attraction between the nucleus and electron. So when I will write attraction, I will always mean the attraction between the nucleus and the electron. So we can say that atomic radius is always inversely proportional to attraction, right? If the attraction between electrons and protons are high, then the atomic radius will be low. Right, A part, variation in group. So what is going to happen in a group? We know that in a group, what happens? The outermost orbit increases. That is why the atomic radius will increase from top to bottom. We'll write here. Atomic radius increases as we go down the group. Due to increase in the shell number, right? I hope you guys know that if we have the second period, then we are in the second shell, right? Acha, variation in group, yani if we are going down the group, if we are in one group, right? We are in the, let us say, first, we are in the first group, okay? So in the first group, what will change? The group is not changing, so the period will change, okay? So second period, third period, fourth period, fifth period, and sixth period. We'll have the second shell, Then we'll have the third shell, fourth shell, fifth shell, sixth shell. I hope this is not very tough to understand. Variation in group. Right, the next one, variation in period. Let me know if I've not written, okay? Second point, A and then B. Variation in period. So if I take this period, that is the second period, we have lithium, we have beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon. So this lithium has 3 atomic number, that is 3. That means we will have 3 protons. This will have 4. This will have 5. This will have 6. This will have 7. This will have 8. This will have 9, and this will have 10. Okay, but we will leave the neon because this is going to be measured as van der Waals. We will see till fluorine because neon is a noble gas. Its measurement is done in van der Waals. Now here it is the number of protons. Number of electron is also 3, 4, 5, 6, 7, 8, and 9. Now I hope you can say that if I have large number of electrons, that if I have very large positive charge and very large negative charge, that means both of them attraction will be higher. Yes or no? Tell me. Attraction will be higher. If I have a large positive and a large negative charge, then the attraction between them will be higher. Yes or no? Please tell me, guys.
Yes, sir.
Right? If we have one, see, if I have, let us say here, one positive charge and one negative charge, and here we have 10 positive charge and 10 negative charge, then obviously the attraction, the 10 and 10 will be higher, right? That is why when we go along a period from left to right, then what is happening, you can see there's an increase in the number of electron as well as the number of protons, but there is no increase in the shell, right? We are adding the electrons in the same shell. That is why the size is not increasing, but the attraction is increasing. The size is not increasing, but the number of electrons and protons are increasing. That is why the size will be decreasing here. Okay, size is not increasing, the size will be rather decreasing because of increase in electrons. Please write. First of all, along a period, the shell remains same. The shell remains same. Next point you will write, but the number of protons increases, right? Number of protons is increasing. Therefore, the Z effective increases, effective nuclear charge increases. Okay. Now, when we have effective nuclear charge that is increasing, that means we will say that the trend will be from left to right. If I go to a period, then the atomic size will be decreasing. Z effective is increasing. The Z effective is increasing. Attraction is increasing, right? And therefore, size will be decreasing as we move left to right along a period. The size decreases. Okay, so what is the trend? The trend is from left to right. Size is going to increase. Write a note. The note that you are going to remember here is regarding nitrogen and oxygen. Okay, so let's see. First of all, there is a slight increase in atomic radius. See, if we are going from nitrogen to oxygen, we were expecting a decrease, but we saw an increase. There is a slight increase in atomic radius from nitrogen to oxygen. Okay, so whenever there will be some type of anomaly, the reason will be electronic configuration. If you look at the nitrogen atom, 7 electron, it has 1s2, 2s2, 2p3. If I look at the p orbital here, the p orbital is having 3 electrons. So you can say that there is no electronic repulsion here, right? All of the electrons, they are individually occupied. All the orbitals are individually occupied. And when we look at oxygen atom, it has 8 electrons, 1s2, 2s2, and 2p4. Now, in this case, the oxygen atom, it has some electronic repulsion. There will be 1, 2, 3, and the fourth electron will go here, and there will be repulsion. And if there is a repulsion between the two electrons, then what is going to happen? When they are repelling, they will be moving away. If they are moving away, that means that they will lead to an increase in size. They will lead to an increase in size. This is the first point that we have to remember between nitrogen and oxygen. And nitrogen and oxygen are going to be very important till the chapter chemical bonding. Even if you, when we are doing the molecular orbital theory that will come, there also this particular point will play a very important role. Okay. Write the next point regarding noble gases. The noble gases are at the end of each period but they don't have least atomic radius. Because for noble gases, we use van der Waals radius. All of you understood these 2 points? Yes or no? Please tell me. About nitrogen and oxygen, everything is clear. Aisha, Devangi, Aram, Fahad, and Fatima. Also Abdullah. Regarding nitrogen and oxygen, is it clear? Why do we see an increase in size for oxygen? Yes or no? Please tell me, guys.
Yes, sir.
No. Yes. Aisha and Aram, tell me. Understood this, Sina?
Yes, sir.
Okay, fine.
Sir,
Tell me, Devangi.
sir, for van der Waals radius, you told that we bring the atoms together.
Correct.
But sir, we can't say that they have a bond, right?
No, they don't have a bond. No, they don't have a bond. Okay, like for example, you have seen ice. You know, Devangi.
Yes, sir.
Ice is made up of what? Tell me. H2O.
Yes, sir.
Right. So there are many H2O molecules like this. Correct. Nearby.
Yes, sir.
But they don't have a bond between them. Na? If I take these two H2O molecules, between them there is no bond, right? Between A and B, if I say there is no bond between them, correct?
Yes, sir.
Okay. Similarly, you have one helium atom here, you have another helium atom here, not so nearby. Okay. So helium atoms, they will be repelling each other. That is why they are. Even this water molecules, they have some cage-like structure. They are not very together like this, but they oscillate around their mean. If I have like this, right? So they will not have any bond. They're just solid state, nothing else. Got it, Devangi?
Yes, sir.
Okay, fine. Chali. Thank you, guys. Thank you very much. This is all about the atomic radius. Now, slowly we'll be also learning about the ionic radii. Okay. And after ionic radii, we'll talk about, first of all, the ions, what ions, cations, and ion. Then we'll talk about the isoelectronic species also. Then we'll talk about the ionic radius. After ionic radius, we will be talking about the ionization enthalpy. That is my next point. Okay, Chali. So major point about the atomic radius is done. You have to look once about the ionic radii, and after that ionization enthalpy. Okay, Chali. Please revise, and also you have a test on. I hope you guys know this. You have a test on the next class, that is Thursday. There will be a test, and this test will be of 10 marks and for 30 minutes. Okay, all the question will be subjective. I think the topic that I have chosen is quantum number, right?